So, good morning students. Already, last class for discussion. So, the topics are, kinetic equations of a motion. Okay, now, so kinetic equations of a motion along a straight line. So, kinetic equations. So, first of all, kinetic equation. So, that is V is equal to U plus AT. V is equal U plus AT. And second one, V square minus U square is equal to AS. V square minus U square is equal to AS. And third one is S is equal U T plus of AT square. S is equal ut plus of AT square. So the kinetic equations in the intermediate level study, that is V is equal U plus AT and V square minus U square is equal to AS and S is equal ut plus of AT square. Okay. So here inverse. So first of all, the body is starting from one point to another point, moving along a straight line. Okay, so the body is moving along a straight line. So the initial velocity of the body is taken V naught or U. Okay, so initial velocity of any body is taken V naught or U. Okay, so the final velocity of the body is denoted by the V. So final velocity is represented by V. Initial velocity is represented by V naught or U. Okay, got it. So now the moving the body, uniform acceleration taken is a small a. Uniform acceleration taken small a. And so in here with respect to time or in time t. In time t. And so the displacement is taken as. Displacement taken as. So now here observe. So V is called as the final velocity, U is the initial velocity, A acceleration, T is time. Now here V is the final velocity, initial velocity and acceleration, displacement. Now displacement S is equal U initial velocity and time, acceleration and time. Okay. So now the derivation of S is equals ut plus of AT square. Very most important 4 marks question in intermediate. Okay. So the first derive S is equal ut plus of AT square by using graph method. That is the VT graph method. Okay, got it? VT graph method. So derive the equation S is equal ut plus of AT square by using the graph method. So now here see. So first of all taken x-axis and here taken y-axis. Okay. So x-axis and y-axis. So the object is moving. Along a straight line in uniform acceleration with some velocity, and the points are taken A or P or Q taken. Okay. So here observe. So here taken. So extend this pattern. So here taken time. Okay. And so V with the velocity. Okay, V with the velocity. So initial velocity is taken V naught or U. Okay, initial velocity. So 0 is the coordinate system. Okay. Here taken V minus or U minus V. Okay. So U minus V. Taken the distance between these two. Okay. So the PQR path are O, A, B, C, D. Okay, path observe here. So O, A, B, C, D. Okay, so the T is time taken on x-axis and V be the velocity on y-axis. So the curve is drawn between V and T. The curve is drawn between V and T. So first of all, so the object is moving the object is moving with initial velocity is v naught or u. The object is moving with initial velocity v naught or u. Okay, v naught or u with uniform acceleration uniform acceleration. Okay, and the velocity is taken v, and to reach the final velocity is v. To reach final velocity is v after t seconds. Got it? So now once again repeat. So the first of all, the body is taken. Consider the body with initial velocity is v naught. Consider the body with initial velocity is v naught or u. In uniform acceleration with velocity is v, to reach the final velocity after t seconds. Okay, got it? So uniform acceleration is nothing but, so here taken, so already we know that uniform acceleration. Okay, so uniform acceleration, take this some velocity, and so 1 second, 1 centimeter distance, 2 seconds, 2 centimeters, 3 seconds, 3 centimeters, so 4 seconds, 4 centimeters, so through along the traveling. So that is called as a uniform acceleration. Now here also observe the just like similar pattern. So the body is moving along a straight line. In uniform acceleration. Okay, clear that? So now the AB is curve is draw, that is gives the displacement. Now OA BCD path. Path gives the displacement of the body in a time t. So OABCD curve gives the closed curve gives the displacement of the body in time t. Okay, in time t. So the body is the displacement is taken. So the curve is or the path is divided in the two parts. Okay, so this is the first part and this is the second part. So the first part, the total displacement, the traveling the body. So the total displacement traveling the body. So S is equal ABC triangle and plus, okay, and OACD rectangle. Okay, clear that? So S is the total displacement traveling the body in t seconds, 0 to t seconds. Okay, 0 to t seconds. So the total displacement S is equal ABC triangle. Okay, ABC triangle, and so OACD rectangle. So ABC triangle, that is the taken. Okay, ABC triangle. So ABC triangle. So half into base. So base is taken t. Okay, in time period t. Okay, base into t. And height is taken u minus v or v minus u. Okay, v minus u taken. And so now taken rectangle. OACD is rectangle and length and width. Okay, so length and width. So length and width is taken, and so length is taken, that is called as a u into taken width is t. Okay, so now taken, so by using the Kinetic equation, so V is equal u plus at. By using the kinetic equation, first kinetic equation, V is equal u plus at. So V minus u is equal at. V minus u is equal at. So now substitute in this equation. So the taken V or minus u. V minus u. So substitute in this equation. S is equal R into T. V minus u. Value the taken is at. A into T plus U T. Okay, so now taken simplification, we get So of a t square plus ut. So s is equal ut plus of a t square. Okay, so this is called as a derivation of the kinetic equation. Okay, so here taken v minus u. Okay, v minus u. So the total displacement of the body of the particle s is equal ut plus of a t square. U be the initial velocity in time period t. A be the uniform acceleration. Uniform acceleration. Okay, got it. So now, discuss the another topic is. So the kinetic equations are applied. Kinetic equations are applied in a free falling body. So the kinetic equations are applied in free falling body. So what is the kinetic equations? So the kinetic equations are, first of all, v is equal u plus at, first kinetic equation, and second kinetic equation v square minus u square is equal to 2as, and third is equal s is equal ut plus of a t square. Okay, so now here taken, so first of all, freely falling body, just like raindrop. Okay, raindrop, just like a chalk is released to reach the ground. Okay, so now take the condition freely falling body. So any free falling body, so initial velocity is taken 0. Initial velocity is taken 0 and the acceleration is taken plus g. Acceleration is taken plus g. Okay, got it? U is equal initial velocity. Any free falling body initial velocity is taken u is equal 0 or v naught is equal 0 also represented. Okay, so acceleration is taken to reach the ground. Okay, so that is taken plus g, that taken as plus g. Okay, clear that? And so now these two applied in this equation. So time period t is equal t. Okay, so now substitute in the first equation. So v is equal, u is nothing but 0, initial velocity is 0, a is taken plus g. Okay, a is taken plus g and time taken is t. Okay, v is equal gt is the first equation in a free falling body. And now substitute in the second kinetic equation, v square minus u square is equal to 2as. So v square taken v square. U square is nothing but initial velocity should be taken 0. Okay, so initial velocity becomes 0. So u square is equal to a. A is taken plus g. Okay, s is taken h. Here taken s is taken, so h is the height, or similarly taken displacement also. Okay, h. So v square is equal to gh. So v is equal under root of 2gh. V is equal under root of 2gh. So v be the final velocity. V be the final velocity of any free falling body by using this formula. So v is equal under root of 2gh. Okay, so just for example, the chalk pieces released, okay, to reach the ground. To find out the final velocity by using this equation. Okay, so find the final velocity of any body, any free falling body by using this equation. V is equal under root of 2gh. H is called as the height. Okay, now take the height above the surface of the earth. Okay, right. So now substitute in the third equation. So the third kinetic equation, s is equal height, s is taken h. Okay, so s is taken, height is h, and u be the initial velocity becomes 0. Okay, so 0 into something also 0. So now we have taken only of a is taken acceleration. Now free falling body is plus g, acceleration is equal to plus g. So plus g. Okay, got it. And time t. So t square. So h is equal of gt square. So 2 into h is equal gt square, and t is equal under root of 2h by g. Under root of 2h by g. So time also find out. Okay, any free falling body. So time taken, time calculated by using this equation. P is equal under root of 2h by g. H is called as the height, g is called as the gravity, P is called as the time taken. Okay, so total equations or kinetic equations are applied in a free falling body. So free falling body, we get the final equation v is equal to gt and v square is equal 2gh, or v is equal under root of 2gh, and t is equal under root of 2h by g. So these equations are implicated or so by using on next problems. So now taken, so another topic is, so for example, a body is thrown to upward direction. Okay, a body is thrown upward direction. Okay, upward direction. So the velocity is becomes zero at an instant at a point. So that point, the velocity becomes zero. At that point becomes taken height is h, maximum height. Height is maximum height. At maximum height, the velocity is becomes zero, but acceleration is not zero. So this note point. Okay. So now projected vertical. Now projected vertical any body. Now projected vertical any body. So the velocity is becomes zero to reach the maximum height, but acceleration is not zero. Acceleration is minus g because so the object is traveling to the earth. Okay, actually the body is traveling to the earth, so the g is taken minus g. Okay, so g is not zero. Okay, observe it. So now another topic is taken. So a vehicle is traveling. A vehicle is traveling in the length is taken L, or like a distance is L. Okay, half of the distance is L. Half of the distance. Okay, half of the distance L. Okay, half of the distance is L with speed or with velocity is v1. Okay, clear that. And another half distance is v2. Okay, is v2. What is average speed? What is average speed? Okay, so once again repeat. So a vehicle traveling along this straight line. Okay, a vehicle is traveling. So first half the distance is L with speed is v1. Okay, so first the half distance L with speed v1, and another half distance with speed is v2. Okay, with velocity is v2. So what is the average speed? So average speed is nothing but, so now already we know that formula. Average speed is equal total displacement or total distance by total time taken. Total distance by total time taken is called average speed or average velocity. Now to find out the total distance and total time taken. So first half distance. So first half distance is taken L by 2. Okay, L by 2. Another half distance is taken L by 2. The total distance. Okay, total distance or total displacement. Total distance. Okay, equal L by 2 plus L by 2. Okay, L by 2 plus L by 2 is taken 2L by 2. Total we get L. L is the total length. Okay, got it. Now taken total time taken. So total time taken. So the time, well, general formula. So we know that general formula. So velocity is equal displacement by time. So the time is equal distance by velocity. distance by velocity. Velocity is equal distance by time. Time is equal distance by velocity. So distance. So first distance is taken L by 2. So with velocity is v1. So L by 2v1 is the first time taken of the distance. Okay. So the body to reach the first of distance taken time t1 is equal L by 2v1. Okay, so now also similar pattern. So T2 is equal. Okay, so another of distance. So time taken T2 is equal D by V, distance by velocity. So another of distance is also taken L by 2. Another of distance is taken L by 2 and by total velocity is V2. Okay, so we can write the formula simplification L by 2v2, L by 2v2. So now find the total time taken. Total time taken. Total time taken. So T is equal. Total time taken T is equal T1 plus T2. T1 plus T2. So T is equal T1 plus T2. So now find already to find the T1. So T1 is equal L by 2. L by 2v1, another L by 2v2. So common taken L and 2. So 1 by v1 plus 1 by v2. Okay, so L by 2 into 1 by v1 plus 1 by v2. So L by 2 v1 plus v2 by v1 into v2. So LCM we get in a bracket v1 plus v2 by v1 into v2. Okay, so now to find the total distance, first point is total distance. So the total distance is nothing but, so first half distance plus second half distance, total distance. Okay, got it. Now, so the total velocity, total time taken. So now already we know the general formula. So v is equal and the velocity is equal displacement by time. So time is equal distance by or displacement by velocity. So distance is taken first of L by 2 and velocity is with v1. Okay, so L by 2 by v1, L by 2 v1 and another time taken, another of distance is time taken. T2 is equal distance by velocity is equal L by 2 by V by 2. So L by 2V2. So the total of time taken, another of time taken. So the total time taken. So T is equal L by 2V1 plus L by 2V2. So we get the final equation L by 2 into V1 plus V2 by V1 V2. Okay, clear that? So these two equations are substituted in the formula. So the total distance taken L and total time taken L by 2 into V1 plus V2 by V1 into V2. Okay, L and cancel. Okay, so final equation 2V1 V2 by V1 plus V2 is average velocity. Okay, average speed or average velocity to find 2v1 v2 by v1 plus v2. Okay, clear that? Okay, so next topic is so problems are solving in a uniform motion. So the body is moving along a straight line. So number of the problems are solved in a next class. Okay, so got it? Thank you, students.